In this video, we're going to get a little bit of practice multiplying and dividing rational expressions, and in particular multiplying and dividing a rational expression with a polynomial. So for each one of these, we're going to perform the indicated operation and simplify, and if applicable, write the restricted domain. Okay. So in this first example, we have x over x minus 5 times x squared. Now, remember this x squared is x squared over 1, right? So the numerator of that is x squared and the denominator is 1. And so when we're multiplying those across, we're going to have x times x squared, which is x cubed, right? You add the exponents. And in the denominator, we're going to have x minus 5 times 1, right? So x minus 5. And can we simplify that anymore? No, we can't. There's nothing to cancel out. So many of these examples, you do the multiplication or you do the division and there's a ton of stuff you can cancel out, factors of 1. In this case, there are no factors of 1 to cancel out. And please don't think you can cancel the x's out there and have x squared over negative 5 or something. No, no, no. Only if you're multiplying the factors in the numerator and denominator and you have a factor of 1 to cancel can you do that. Okay, so we're done there, and the domain restrictions, we haven't canceled anything out, so there are no hidden domain restrictions to talk about. Okay, so now in this next example with y to the 10th times y plus 1 divided by y to the 5th, same thing here, right? We've got y to the 10th over 1. And in this case, y to the 10th over y to the 5th, we've got 5 of these downstairs and 10 upstairs, right? So 5 of them will cancel out, and we're going to be left with 5 of them upstairs, yes? Okay, so then we've got y to the 5th times y plus 1. And I would add to that, y can't be 0, right? Because we canceled out that factor of y to the 5th. If y is 0, that makes the denominator 0. Very good. All right, so now let's look at some of the division examples here. So if we have 20r divided by 4 divided by r squared, that's equivalent to 20 times r to the 4th over 4, right? So we have to multiply by the reciprocal of the divisor. If we're dividing by 4 divided by r to the 4th, we have to multiply 20 by r to the 4th over 4. Okay, now 20 over 4 is 5, right? So we're going to have 5r to the 4th. And also, tell me that r can't be 0. Now, why would that be important here? Because in the end, when we multiplied by the reciprocal, that r to the 4th became part of the numerator, right? So we don't have a denominator there, so it might help to think about how this problem originally looked. So if we think about 20r divided by 4 divided by r to the 4th. That r to the 4th was originally part of a denominator, right? Two denominators, actually. So we definitely have to say that r can't be 0. All right, so now let's look at this one. Now we've got t plus 2 quantity squared over 6 divided by t plus 2. Okay, now remember that t plus 2 is over 1, right? So if we multiply by the reciprocal of the divisor, we're going to have t plus 2 quantity squared divided by 6 times 1 over t plus 2, right? Okay, so let's look at this. So t plus 2, there's one of them in the denominator and there's 2 of them up top, right? So we end up with one of the t plus 2's on the top, and on the bottom we just are left with 6, right? Now we also want to say that t can't be negative 2, right? Because again, we were dividing by t plus 2, so t plus 2 initially was a denominator, right? Just because it only exists in the numerator in our final simplified form doesn't mean that it wasn't part of the domain restriction of the original expression, okay?